Okay, this is our Math 2460 Zoom meeting for Friday, what's today? The 18th, September 18th. Appreciate y'all coming out early on a Friday morning. Y'all got any questions? Start with?
I don't think I have any questions, but so we ended last meeting with doing the volume out of a cube, or the work taking to get water out of a cube tank or a rectangular tank, and we were gonna do the other shapes.
Okay, yeah, we can do that. Does anybody have any questions? Did you all get the test 2 blank form and test 2 question form with them all worked out?
Yeah.
Are the directions crystal clear about how to get on D2L and find the actual test where you submit your answers?
Yeah. Everything seemed all good.
All right. I didn't really get any messages that anybody had any problem finding the practice quiz. So that all worked, and you downloaded, what's that thing called? Respondus Monitor?
Yeah.
Okay. Yeah, see, I don't have the download Respondus Monitor button, so I'm telling you to do all these things that I can't see your screen and where the buttons are or anything. I'm just, kind of going blindly that everything will work, and I haven't got any complaints that it hasn't, so hopefully it is working.
Yeah, it should be pretty self-explanatory because I'm pretty sure even if you try to click start the test, it
Right.
automatically downloads Respondus for you, basically forcing you to go through Respondus. So there's no way to really get around it and no way to mess it up.
Okay. It's just that I guess they make us do the practice quiz just in case there's some sort of problem.
Yeah,
And then all of a
that
sudden
makes
you
sense.
can't, right. And then all of a sudden you can't complete the test. Okay. Yeah. And the other thing is, I would doubt that it's exactly the same way to enter your true or false answers. In other words, by typing literally, like the Google form, typing literally true with a capital T and F with a capital false. But I can't see exactly what they're going to make you do. I hope
Yeah,
it's I hope it's as simple as true and false are on the screen. You click on one or the other.
it's probably like a bubble click one or two.
Yeah.
What the big thing that I'm I feel that might mess some people up is normally whenever they do these, they automatically randomize them. So it won't be question one is not question one. It might be just like question three is question one, and then question five is question two.
Oh boy.
Yeah.
Now, okay. Let me think here. Um,
I'm not sure that's how that works, but I know whenever I've done like these in the past, last semester, they were someone like mixed up where like one person had a different question one compared to my question one.
well, I don't I don't know if I've avoided that or if I've just made a big mess. Let me tell you what my vision of it was. On that test form in D2L, I tried to make it look as identical to the Google form as I could. In other words, it reads question 1, true or false, the problem is correct. Question 2, true or false, the problem is correct. So all the questions in the Google form are absolutely identical. And I'm hoping that means if it did randomize, it doesn't matter. They're still identical. So you can take question 1 on, not the Google, but question 1 in that D2L form to refer to question 1 on that test form I gave you.
Wait, so like in the question, like is number you wrote like is number one true or false? Like,
Right.
you know what I'm saying? Yeah. So then basically, if anybody's just paying attention, they should be all good.
Okay. I hope.
Yeah.
But
Hopefully, yeah.
that's why I see it doesn't let me include those test forms inside the D2L. You basically get one thing. So if I had included inside D2L, I'd had to completely retype it.
Yeah.
which or rewrite it, which I was not willing to do. I'm a
Makes sense.
lazy.
I wouldn't want to do it either.
Yeah. So that's why I set those separately as separate emails. And I set the blank copy because someone complained, or didn't complain, but someone wanted a full blank copy of the test. And then I set the separate copy with the problems all worked out. So you can use that during the test. Obviously, that's what the D2L form will refer to. Problem 1 on the D2L form will refer to problem 1 on that test form.
Yeah.
So I'm hoping if it did want to scramble them, who cares?
Yeah, it should just still say everything that.
It'll still say problem 1, problem 2, problem 3, etc. That's the way I'm hoping it works. Like I say, it's my first cut through it. We'll find out if this works well for y'all. And so far, from my end, I haven't had too many problems. It'll hopefully work well with my other 3 classes.
Yeah.
Yeah, and anything else?
No, I don't think so.
Did you want to see those other 2 geometries then?
Yeah.
Okay, so we're talking about problem 21 first here.
Yeah, I think it was the cone and the cylinder were the other 2 shapes.
Okay. Yeah, 23 is the cylinder. If I can fold it over, yeah, it's up here. All right, we'll do 21 first and then go to 23.
Solid.
Okay. So this is 2460, page 491, section 7.5, problem 21. All right, really quick, they're trying to help you out with these diagrams pretty much by giving you the distance pump. They give it to you right on the diagram. Now they're lining up the tank on the x-axis, which is ground at -2 here and 2 here. And the tank, though, is only 4 feet high. This is at 4, and they're pumping it up to 5, which is ground level, they're calling it. And so they're giving you this 5 minus y. You can basically take that as equal to the distance pumped, even though it doesn't directly say that. But it comes out of the wording. So you got a cylindrical tank, 4 meters high, radius is 2 meters. Buried, top of the tank is 1 meter below ground level. How much work is done pumping the tank full tank up to ground level? And they, instead of using the 62.4, they've switched units to newtons per cubic meter, 9,800 newtons per cubic meter. And so that's what we're going to start with. This is work, 9,800, and we're in newtons per cubic meter. So in the metric system, or they call it MKS, the unit of force is a newton, after in honor of Isaac Newton, not a pound. All right, once again, we'll need a volume. That will be in cubic meters. And we will need the distance pumped. And they basically have pretty much given us that. That will be in meters. And so you see we can work this out, and the units will come out in Newton meters instead of foot pounds for work. That'll be the energy done. All right, if you remember the other problem, I'll go ahead and drop the units, and then volume is area dy. I'll go ahead and put in the 5 minus y for the distance pumped. Can you tell at y is 4, 5 minus 4 is 1, and you've pumped water at the top of your 1 meter, where if y is 0 down here, it's pumped all 5 meters. 5 minus 0 is 5. Now the area on this one, see, is different from the fish tank. The area looking down, you see circles, pi r squared. And the r is 2. So we've got 9,800 pi times 2 squared dy, 5 minus y. Have we lost anybody? Should we pause for station identification?
I think I'm good. Wait, so is the pump is the I don't have my book up by me, but is the tank 5 meters tall
No,
or
it's 4
five?
no,
It's 4 meters.
the tank is 4 meters tall. Yeah, we can show you this. The tank, so you see they're showing you up to four tick marks here,
Okay.
but they're pumping it up to, I don't know why they have to word it so crazily. It's really not as complicated as they're trying to word it.
Oh, okay. I see that. Yeah. Okay, I understand that now. Yeah.
In effect, they're pumping it 1 meter over the top.
Okay, that makes sense. Yeah. Thank you.
In effect, yeah, I didn't draw it up here. When you drew your little rectangle up here and you look down on it, you see circles. And the radius is constant. It's like a beer can, Coke can. The area is pi r squared and the thickness is dy. So the volume of your little sliver is the circular area of pi r squared with r of 2, and the thickness is dy, and that's the volume of water you're pumping up out of the tank. I don't know, you probably think this has no practical application whatsoever, but anybody live in Hall County? Out in the county, not in the city, like me? Well, I don't know if you've ever sat, having to go to the restroom and doing your business in there. You ever sit there and scratch your chin and just wonder, where does my poop go? Well,
Uh,
if you're,
I've been to the waste treatment facility there.
oh, okay.
Yeah, I went
Well,
for a trip.
yes, it does ultimately. Okay, now if you live in Hall County, it doesn't wind up in the waste treatment facility. That's the point. If you live in Hall County, your house in a subdivision is more than likely on a sewage system. I'm sorry, is on a septic tank. So your sewage winds up directly in a septic tank, which basically does look, if you ever seen them running around town, look like this, and was buried in your yard about 10 foot from your house, according to Hall County septic tank codes. Basically looks like an a concrete fish tank. And if you're smart, you will have, or your parents, you may not be old enough to own your own septic tank yet. That's something you have to look forward to when you buy your house in Hall County. Your parents will have that thing pumped roughly every 5 years. And you see the sewage tank trucks running around town, and there's enough houses out there on septic tanks for business for them that they will come and dig out the entrance to your septic tank and will pump out your human waste into their truck and haul it off, or usually between $300 and $400 about every 5 years. You ever sat around your house and watched your folks have this done?
No.
Okay.
I know my house works on like a septic field, so it's like
Well,
different.
right. Your septic tank is usually about 5,000, I don't know, about 1,000 gallons. It probably takes about a week of doing laundry, flushing the toilet, et cetera, to fill that up with liquid. Your solids go to the bottom of it, and it takes 4 to 5 years for the solids to build up enough to need it pumped. Since the liquids fill up, there's a hole out of the septic tank that goes into septic fields, and there's lengths of those by Hall County codes, and then ultimately it gets absorbed into the soil in your yard. Okay, that's probably way more than you wanted to know. And maybe we can't relate math to your real life at all. But yes, somebody figured out the energy required to pump your septic tank, if you have one. But to finish this, you pull all the numbers to the front. I guess I'll call the 2 squareds the 4, put the 4 pi at the front. You'll have your 9,800, and you'll have your integral of 5 minus y and dy. Okay, the limits. Once again, it just asks for a full tank. A full tank of water up to ground level. So that's where we're bringing in that the tank is only 4 meters high. The tank or the limits go over where the water is, and that's where the 9,800 is valid. The 9,800 isn't valid in this last meter of air. So the limits on this go from 0 to 4 meters. Integral 0 to 4 where the 9,800 is valid. And it's valid where your water is. So it's pretty simple, and it winds up being a pretty simple integral, even though the setups look complicated. Anybody want to take the time to see it punched, or you have any questions about it?
I definitely feel the hardest part about this is just finding the limits.
Yeah. The limit, that's where it gets tricky. The limits, you just got to think, are where the 9,800 is valid, and it's valid inside the tank. It's not valid. This is air up here, not the 9,800 between the 4 and 5. Are you ready for 23 then?
Yeah.
Okay, now 23 is going to be even more complicated, but it's got the same idea as this, meaning you're going to look down and see circles. But in 23, they have narrowed in the sides to a point right here. In effect, looking like an ice cream cone. So the radius, you're still going to look down and see circles, but they're not constant too, as if the sides were straight perpendicular, like on the straight cylinder, which you see a lot. You don't really see a lot of tanks like this around town balanced on a single point with no visible means of support. But that's what math does. It makes you do, it messes with some kind of completely impractical stuff you'd never see in the real world. So draw this out real quick. Yeah, the tank is 8 feet across the top. This is problem page 492. 92, problem 23. Okay, you got your tank at the top, 8 feet across. That'd be a diameter, which means your R is 4 feet, but you narrow in the sides. Okay, 6 feet high. Emptying the tank by pumping the water over the top edge. And notice they also give you your 6 minus y, which you can take to be distance pumped. Okay, when you do your little sliver across and look down, you see circles. And those, the area though, with dy of thickness, and your area is pi r squared. But the r is not 4 all the way down. So let me set this up. I'll come down here so we can use some scratch paper up here. Your area is still going to be, you're back to water, and we're going to go back to the 62.4 pounds per cubic foot times volume. Again, that's in cubic foot times your distance pumped. That will again be 6 minus y. And the volume will again be area dy times 6 minus y. Looks like ready. I guess I should have left a little more space here. Area times dy. Now your area here again will be pi r squared. dy, 62.4, 6 minus y. All right, we're going to have to find r. Okay. If you'll notice, the r up here, r is aligned with x. So we can use x, or set r equal x. We'll just call it x out, since it's the x-axis out and it's directly aligned with r. So we can call area equals to pi x squared here. Okay, area equals pi, then x squared. All right, to find x, we need the equation of the line. Y equals mx plus b. Remember your basic college algebra, the b is the y-intercept, and it equals 0 here. Your b will be 0. Your m is your slope, rise over run. And the rise is 6, the run is 4. 4 down here. Radius at the top is 4, so coming out here, your rise is 6, your run is 4. So y equals 6/4 x. All right, you can then reduce the 6/4 to get 3/2. Pause here since I got to go on the next page anyway. Have we lost anybody?
I think I understand this.
Yeah, the reason you have to do this is because that radius is changing. You can see this from the, if x is 0, or your radius is 0 down here, then your y height is 0. And if your x is, what's that x going to be? Out there. Well, x is 4. Yeah, if x is 4, 2 into 4 twice, 3 times 2 is 6, then your height is 6. That makes perfect sense to me. All right, well, now you got to twist it around. This means your x, multiply both sides by 2, 2y equals 3x, divide both sides by 3, and x is 2/3 y. So that is your form. That's how your radius is varying along these circles. You see if y is 0, your x is 0. And if y is 6, 12/3, yeah, your x is 4. Or radius is 4 at the top when y is 6. It goes by this equation. Sorry, it goes by this equation. This is your radius.
And then you're just going to plug the 2/3y into, so it'd be pi 2/3y squared.
Where? Absolutely. The rest of this is plug and chug. You just need to know That's how to get what to plug and chug into. That's right. We're going to plug this X right there. So next page, if I can keep it all visible. Hard to do. There. Okay, my work, 62.4 times pi times 2/3 y squared dy 6 minus y. So yes, 2/3 y goes in for that r, and then squared. Same game, numbers to the front, y's to the back. 62.4 pi times 4/9. 2 squared's 4, 3 squared's 9. I'll write it out one more thing. Y squared dy 6 minus y. So the work done will be, I'll call it 4 pi over 9 times 62.4 integral y squared 6 minus y dy. And once again, what are the limits? Well, the tank was full and we're emptying it just at the top. It would go from 0 to 6. Questions about that? This is so amazing. Everybody is speechless.
This seems pretty easy. It's just like you just have to understand what you're doing. Like you have to like step back and be like, okay, how does this all work out?
Yeah, and they all have to be worked out individually. So this did not work like the straight cylinder in 21 because you have to do this extra stuff. Your radius is varying. Whereas in 21 with a straight cylinder, that was 2, or it was pi 2 squared. The radius was a constant 2. And in the aquarium, the first big box tank we did on Tuesday's Zoom was 5 times 4. Is there anything else we can show you all off these problems? We've released the test, so you can be working on that for.
I think I'm good for a day.
Can we do number 13 on page 491 in the textbook?
Yeah, that's kind of a backward spring problem. You're talking about this one right here, right?
Yeah.
Sure thing. Let me go to the top of a clean sheet because this one could get a little long. Yeah, it's a little weird way to find your K on this one. It's kind of backwards. I was 13. 7.5, page 491. All right. Your work is 18 foot-pounds. To stretch a spring 4 inches from its natural length. They're not going to tell you, they're not going to give you the natural length. Okay, so the purpose of that sentence is to find K. All right, we'll call this its natural length. And we'll take that to be x equals 0. Since you can give us enough. if they had given us a number, we'd ignored it, which they did, like number 9, they said it was 15 inches or something. We ignored it and still called it 0. There's no force on it, on its natural length. Okay. And then you're going to, at this point, stretch it 4 inches. All right, all you can go by is that work, integral from A to B of your force, f of x dx. This is force. Or your spring, that's kx dx. Okay, the 18 foot-pounds goes over here. That's the work. Instead of giving you this stuff and having you just, compute it and find the work, this one gives you the work. All right, the A to B, that 18 foot-pounds stretches it from its natural length out 4 inches. So that's going to run from 0 to 4. Kx dx. Now you're used to being able to punch these things, but you can't directly with the K. But don't forget, K is just a number. You can do this and actually just punch this if you want. Or we could work it out by hand. You want to see it worked out by hand, or do you want to just punch this part?
We can just punch it in because that's pretty simple to do. So.
Okay. So you can punch it in on yours or watch me. Basically, you want to go math 9. Just a straight x, comma, x again for the dx, comma, went from 0, comma to 4. Works out 8. So in effect, you have 18 equals k times 8. That went too fast. So to solve for k, you're dividing by 8. K is 18 over 8, 9 force. So your force is 9 force x. Now we're ready for the second sentence. Find work to stretch an additional 3 inches. This gets tricky. The wording is very tricky. To stretch an additional 3 inches. Well, that work will be the integral of 9 force x. So my force is 9 force x. So I've worked out to that. Should we pause for station identification? Any questions about this?
I'm good.
Okay. This is where things get tricky. An additional 3 inches implies you're starting at the 4. An additional 3 would put you up to 7. So the limits on this should actually run from 4 to 7, not from 0 to 7. It didn't say find the work to stretch 7 inches. That would go from 0 to 7. It's just an additional 3 inches. That's additional beyond the 4, at least the way I read it. And so the limits would actually go from 4 to 7 for an additional 3 inches. Questions about that?
No, I got it. Thank you.
Okay. You want to see it punched or?
No, I punched it in and I got the correct answer from what it says in the back of the book.
Okay. Very good. Y'all have anything else you want to see? Looks like we've got 5 participants. But I'm on my screen with this camera here. I can't see your names, but I've got 6 total. One of them's me. So 5 of y'all out there came out early on a Friday morning.
I think I'm good for today. I actually have to head out.
Okay, yeah, no
Thank you.
problem at all.
Yeah,
I
thank
can't
you
see
for
when you
this.
leave. Yeah, so no, it's no big deal.
Have a good day.
Same to you. Appreciate you coming out. Anybody else want to see anything? Hearing silence, maybe just for completeness, I will punch it myself. Nine force x comma x comma 4 comma 7. You get 37.125.
Yep.
Okay. Show that. Does anybody want to see anything else? Any other problems? We'll keep the same schedule of Zoom meetings next week. We charge into Chapter 8. Chapter 8 and Chapter 9 are the toughest sections of the whole course. Coming attractions. Not hearing anything else. Y'all ready to end then? Can't even get a hip hip, or are y'all looking for questions to ask?
I'm just looking for a question real quick.
Oh, okay, sure thing. I'll stay on.
Okay, I'm good. Thank you. I couldn't find a question.
Sure. Is this off WebAssign or out of the book?
Oh no, I said I couldn't find a question. I think I'm all good.
Oh, you sure? Okay. Well, you can always email me if it comes to you.
All right, thank you.
Sure thing. Anybody else have anything, or are we ready to end?
I think we're ready to end, but thank you for your help.
Sure thing. Glad to do it, and I appreciate y'all coming out this morning. We'll go ahead and end, and maybe I'll be around next Tuesday. Keep the same schedule. We'll end the meeting and see you next week. Thank you.
Thank you.